Alright, so here's my robot working. I have a Cheez-It box to demonstrate. Gotta hold it down too, because I do have to push it down a little bit to get it to move forward. And what that does is it creates a little dimple so that the edges of the box can get a little bit closer. Which makes it not perfect, but it does work decently well. So as I bring it closer, the arm will start moving like that, and it will try to just touch. It should try to just touch the Cheez-It box, and it kind of does. And as I bring it closer, the arm shrinks in size, and now I have to start pushing it a little bit. And right about there is where it will stop because of the arm size. And as I pull it away, it kind of follows the Cheez-It box. And once I get to a certain distance, about right there, it gets mad because it can't touch the box. And then I bring it closer, and it stops freaking out a little bit. And I can do it again. Bring it closer. I'm pushing on it now, and pull it away. And it follows until it gets angry. And there you go. Alright, so this is my first SDL project. My goal was to make a robot that changes its two arms, changes the angle of its two arms to touch an object a known distance in front of it. So here's the robot. It just changes the angles of these two arms to touch an object that's right here, certain distance in front of this ultrasonic sensor. My learning goal was to use as much vector math as possible to do this project. And another goal I had was to write down all of the equations, specifically and neatly, this is what I did initially, and I also wrote them out down here so I can better explain them. Another goal I had was to understand all the vocabulary and the notation for all the math involved. And another goal I had was to execute the project with good planning. The math, I think I did a pretty good job. The building and design, I did not. Alright, so this is Servo 2 and this is Servo 1, like it shows right here in this drawing that I made early on. So the equation I decided to use was an equation to calculate the angle between two vectors. And so basically how that worked was you take a distance, the distance an object is from this ultrasonic sensor, cut it in half because these arm lengths are supposed to be 60 millimeters. And basically this first arm will take half the distance, the second arm will take half the distance, and I treat these arms as vectors, and I treat the distance horizontally halfway between them also as vectors. So to start this equation, I need an equation to figure out how far the object is away from the ultrasonic sensor. And so I found a tutorial on the Arduino website that talks about how the ultrasonic sensor works, and basically what it does is it just sends a sound wave, waits for it to bounce off of something, and then it hits the other sensor, which is what it shows right here. And so the speed of sound is 340 meters per second, but the ultrasonic sensor measures time in microseconds. Or maybe that's what Arduino does, but so I needed to convert it to microseconds. And also, the arms are in lengths of millimeters, so I also have to change it from meters to millimeters. So that's what this little conversion table is right here, just 340 meters per second. For every 1 second, there's a million microseconds, and for every 1,000 millimeters, there's 1 meter. Doing that gives me a velocity value of 0.34 millimeters per microsecond. Now the time value right here is cut in half because the time it takes is double the distance. It has to go out, hit the object, and then come back. And we only want to know how long it takes to just go out and hit the object. So I have to cut the time in half to get the correct time. And since distance is equal to the time times the velocity, knowing these two variables, I can calculate how far away the object is from the ultrasonic sensor. And now that I have that distance, I can cut it in half and call it A. And that's what this vector is right here, just the horizontal vector, half of 120 millimeters, because that's what the two arm lengths are supposed to be, 60 millimeters each. That's 120 millimeters total. So that's vector U. The X is just A, and the Y is 0 because it's horizontal. And the vector V, I know the magnitude is 60 millimeters because that's the length of the arm, but I don't know the variable A, which is the horizontal distance, and I also don't know the variable B, which is the vertical distance. That's what I'm trying to figure out. And that's where the equation right here comes in. That gives me the angle between these two vectors. So since I know that vector V is AB, I can dot that with the other vector U, which is A0 because it's horizontal. And dotting those, you just do A times A, which is A squared, and B times 0, which is 0. So you get A squared. And then on the other side of the equation, I have the magnitude of vector V, which is 60 millimeters, and the magnitude of vector U, which is just A, times cosine, so 60A cosine, just some simplification here. And then if I take the inverse cosine, divide by 60A to get it all on one side, take the inverse cosine of A squared over 60A, that gives me this angle right here. So I know what angle A is now, and angle B is just angle A plus 90 degrees minus 180, which is negative, but just flip it over. And then these two angles have to add up to 90 degrees, so I can just subtract whatever this angle from 90 degrees, and that'll give me what this is, and it turns out to be A. These two angles are vertical angles, so they're the same. And what this dotted line is right here is whenever I move the first arm up by an angle A, this arm is still vertical, so I have to move it by angle A to get it to be horizontal again, and then I have to move it by angle A again to get it where it needs to be. And that's the gist of this right here. So the angle for servo 2, which is this servo, is just angle A, and the angle for servo 1, which is this servo, is 2 times A to get it down to the right angle. That's what was supposed to happen. What actually happened is that I just didn't feel like taking the time to properly figure out how to model everything, and so I just made them kind of arbitrary lengths, basically. And so this arm ended up being 66 millimeters, and this arm ended up being 54 millimeters. So now these two angles aren't the same. I also multiplied them by a ratio right here. So 66, which is this length, over 60, which is half the length of 120, equals 1.1, and 54 out of 60 is 0.9. And what this does is, at least I think, I didn't really think about it much, I just thought of putting it in there. Basically, it gives more of the length of A to the longer arm and less of the length of A to the shorter arm, so they both contribute equally, is how I think it works. Although, to be honest, I'm not completely sure. And then from there on, same thing, so take the distance divided by 2. Now we multiply by that ratio to make the A lengths proportional to how long the arms are. And between not doing this and just dividing by 2, I didn't really notice a difference, but I did it anyways. So now that I have two different lengths, I need two different equations. This one with 66 for this length right here, and this one with 54 for this length right here. Other than that, the equations are pretty much the same, although the A's are different. And I put this one for servo 2 because that's that arm, and this one for servo 1, which is that arm. Now we move on to the last step right here, which is calculating the final angles. So I know what this angle is, and I know what this angle is. They're no longer the same, so this one's A, this one's C, and these angles are no longer the same, so this one's B, and this one's D, using the same, just geometric identities, I guess, as before. these two angles are the same, and this angle is the same as this angle, but now this angle is slightly different. It's this angle, and that's what I wrote here. So the angle for servo 2 is the same, angle A, and the angle for servo 1 is now angle A plus angle C instead of 2 times angle A. And doing that math makes it work decently well. And so that's basically all the math that I had to do. Really just one vector math equation and this equation to figure out the velocity, which was given to me right here. Just had to change it a little bit. And that's it.